More than 9 decades of serving the nation. Central Board of Irrigation and Power.
Okay, so today we will be discussing regarding bus bars. How bus bars are designed, what is the importance of bus bar, and then how to decide or how to calculate the sizing of the bus conductor. Bus bar is the rigid conductor and flexible conductor. Selection and sizing, current carrying capacity, allowable short circuit current etc., short circuit forces and spacer span. There are various schemes for the bus bar, that is types of various schemes we will be discussing, like single bus bar scheme, single bus bar with sectionalizer, then double bus bar with single breaker per circuit, then double breaker with 2 breaker per circuit, then single bus and transfer bus, double bus and transfer bus, mesh arrangement, 1.5 breaker arrangement. All these things we will discuss and what are the pros and cons of all the schemes. Basically, design consideration for the bus are the maximum reliability. We want maximum reliability of the substation. The reliability means the power supply should be available at the substation when it is required, and we require power supply at all the time, so power supply should be available at all the times. Then it is reliable. Flexibility. We will be able to change the configuration or change any system configuration. Then it should be flexible. Then continuity of service, and we have to achieve all these objectives with the least possible cost, and keeping in view the safety, statutory safety conditions also. The factors which are considered for substation design are reliability, then economy, safety, and simplicity. Then these are the various components in a particular feeder: transformer circuit HV side, transformer circuit LV side. Okay. Now, point to be considered while laying out the substation. Substations are the important part of the power system. Continuity of supply depends on a considerable extent upon successful operation of the substation. Basically, we have to design and install substation equipments in such a way that the substation is reliable and it is safe to work. For safety consideration, maintenance of the regulars, we have to provide regulatory clearances from one phase to other phase, and then from phase to ground. Working clearance, or we normally call it safety clearance, we have to provide, so that the worker can safely do the maintenance work. For reliability, it should be good design and construction, provision of the suitable protective gear, easily operated and maintained, and it should involve minimum capital cost. Now, bus. Basically, bus is a conductor in the switchyard on which all the incoming and outgoing feeders are terminated. That's why we have named this particular conductor as bus bar, because it is common for all the feeders of that voltage level. And in a feeder, there are various components for control, monitoring and operating of that particular feeder, and the assembly of all the equipments for a feeder is called a bay. Okay. Now, the components in a particular feeder are connected in a particular sequence, and that sequence we cannot change, because each and every equipment has to perform its own specific work, so we cannot change the sequence. So all the equipments in a bay are connected sequence wise from start, that is from LA up to the bus, and that is depicted with the help of a signal line diagram. Now, substation layout and bus bars. Selection of the bus bars. Basically, there are two considerations. One is what type of bus we are selecting, what type of bus arrangement we are selecting, and then what is the size of that bus. In case of air insulated substations, the bus bar could be either of the strung bus or flexible. We call it flexible bus. Means it is strung from the gantry. Flexible and in this particular bus, flexible stranded conductor is used. And we do the stranding of the conductor only to increase its flexibility. So this particular strung bus or flexible bus, it is suspended from the gantry, you can say. Insulators are upside. Now rigid tubular bus, rigid type with the tubular aluminum bus conductor. In the rigid bus, we are normally using aluminum pipes as the conductor of electricity. And these aluminum pipes are installed on the post insulators. It means insulators are downwards. In the strung bus, it is upward. Now, conductor rating, what shall be the conductor rating and how many conductors in one particular phase, that will be decided depending upon the power flow requirements, how much power we are to carry, corona effect, ambient conditions, then the broad comparison of the, then these are the three factors. Power flow requirements, it means we have to select the conductor according to the how much current we want to carry. And then corona effect. Now different conductors are used, different ACSR conductors used. Okay. Now first of all, I told you that for the flexible bus, we hang the bus from gantry. How many insulators are provided in that bus? And how to calculate the number of insulators, the number of disc insulators provided in that string, suspension string for the bus. Suppose
upon the voltage.
that will depend upon the voltage, yes, because we are providing the disc insulator to provide insulation, and insulation is according to the voltage level. But suppose it is 220 kV, we are designing a 220 kV bus, then how many insulators should be provided in one particular string? Uh,
20.
20.
20.
Okay. It means 220 divided by 11.
Yeah.
You have calculated like this. Okay. So we have to provide this disc insulator and hang this. The voltage of this is 245 divided by root 3. Then divided by 11, it is 12.8. It means minimum 30 disc insulators. 13. And we add one more for safety so that with the fluctuations in the voltages, no bus fault should occur. So therefore, normally we provide 14 on the suspension string and 15 on the tension string. We add one more for the tension string because we don't want that the fault should clear at the tension string. We increase the resistance of that particular path. So this is the corona effect. To reduce the corona effect, we have to increase the effective diameter of the conductor. And effective diameter of the conductor can be increased by putting 2 or more conductors in one particular phase. So it means we use bundle conductors. In not one conductor for one bus, we use normally 2 conductors or more conductors for one particular phase, so that the effective diameter of the conductor increases and corona effect is reduced. Okay. So various types of conductors which are used for the strung bars are: number 1, double AC conductor, means all aluminium conductor. There is no steel bar, steel stands in that, all aluminium conductor. Then triple AC conductor, all aluminium alloy conductor. All stands are of aluminium alloy. Then ACAR. ACAR is aluminium conductor, but the reinforcements is provided with the help of the aluminium alloy. It becomes ACAR. Then ACSR, which is normally used, because mechanical strength of ACSR is best. So, and we can provide bigger spans in the switchyard. So, normally we use ACSR. This is aluminium conductor with steel reinforced. And nowadays we are using a special type of conductor which is AL59. This is high temperature, no sag conductor, STLS conductor. The advantages of using these flexible conductors for the bus bar are use of the same material employed for the overhead lines, because same material is used for the overhead lines and that is available. Again, the point which I discussed yesterday on Thursday, that we have to maintain less inventory if we are maintaining the uniformity. So same conductor is used, beneficial. No extra conductor is required to be provided as reserve for the bus bars. Then bundling of multiple conductors with the appropriate diameter in UHV substations will reduce the corona effect. Disadvantages: complex layout, difficult to verify the capability of the transmission, capability to withstand the electrodynamic forces. Okay. Then we come to rigid tubular bus. Rigid tubular bus conductors are used for the bus bars. Rigid tubular buses are more advantageous than the flexible conductors. It is simple. Number of levels in the layout reduces, because with the ACSR conductor, flexible conductors, we are using normally 3 levels, but here 2 levels will be sufficient. Easy access to the transformers or to the switchyard for maintenance. Easy use of pantograph or semi-pantograph isolators. Easy for the substation extension. Then easy verification of electrodynamic forces effect, short erection time, lower grounding area for the plant installation. The only thing we need a special type of jointing technique, that is bridging. We need to have at the substation by erection. Otherwise, it is very easy. Disadvantage: uneasy for the temporary bypass of the circuit breakers on both sides of the bus bars, and possibility of mechanical resonance between the structure and the wind gust frequency. Now, The factors which are required to be considered while selecting the bus bar sizes are normal current carrying capability and short circuit heating withstand capability. Now, while for the layout of the substation, what is layout of the substation? It is a physical arrangement of the equipments in the substation relative to one another, and layout is illustrated by a single line diagram. It influences the operation, maintenance and cost. And these layout schemes, various layout schemes, the advantages and disadvantages of various layout schemes, layout of the bus bar schemes are considered while designing the substation. Now, first of all, we should know what are the various schemes. Single bus bar with sectionalizer, then double bus bar with 1 breaker per circuit, double bus bar with 2 breaker per circuit, main and transfer bus, 1.5 breaker arrangement, then mesh arrangement, the ring arrangement. Now, which type of bus arrangement we prefer will depend upon the advantages and limitations of various bus schemes. So, we'll come to the design afterwards. First, we should know what are the various schemes and what are the advantages and limitations of various schemes. This is the single bus bar scheme. Now, at one particular substation, we don't use one type of bus scheme only, because there are various voltage levels. At a 220 kV substation, we are having other voltage levels also, say 33 kV, then 11 kV, 400 volts. So all at all the voltage level buses are required, and different bus schemes are used for different voltage levels. This is a single bus bar. It means there is a single bus bar, and all the feeders of that voltage levels are connected to this single bus bar. Advantages: simple operation, simple construction, initial cost is very low. It means initial cost of the bus bar is very low, and maintenance is also very less. But the drawbacks are that in case of any fault on the bus, then the complete system of that voltage level will be dark, because we don't have any other further arrangement. So that particular voltage level will not work, and if it is used for higher voltage level, it means the total substation will dark. And if we are to maintain the bus, we have to put the bus under shutdown, and it means the complete substation will be out. Substation cannot be extended. Now, for extension of the substation, what we do? We erect the equipment in the adjoining bay, but when we have to connect with this bus, the substation will be dark, because we have to take shutdown on the bus bar to connect the extension bus with the existing bus. Substation will be dark. So, and they least flexibility. We cannot. They least flexibility, because the length of the bus is limited. The number of feeders on that bus which can be connected are also limited. Then another arrangement is single bus bar scheme with the bus sectionalizer. In this, single bus had been divided into 2 sections with the bus sectionalizer. In this bus sectionalizer, there are 5 components: 1 circuit breaker, 2 isolators, 1 on either side of the circuit breaker, and 2 CT, 1 on either side of the circuit breaker. Half of the feeders are connected to bus section 1 and rest half are connected to bus section 2.